In recent years, neural networks have become the heart of the technologies we use every day. From the public's point of view, they are often seen as the invisible engine behind many artificial intelligence applications. A prime example is generative artificial intelligence, a branch of AI that has existed for some time, but has only come to the forefront of public discussion in the last 2 or 3 years, thanks to the spread of large language models, or LLMs. These models are nothing more than extremely complex neural networks made up of billions, sometimes even trillions, of parameters. The parameters are the threads, the connections between the artificial neurons which we have described. These networks are trained on enormous amounts of text, and through this process, they learn to build a probabilistic model of natural language. There is a statistical representation of how language works. If we look at the size of these models, we realize their scale. It's impressive. We're talking about a few billion, hundreds of billions, or even trillions of parameters. This makes them enormous models, complex to manage and to understand. Furthermore, many of the technical details are not publicly accessible, since these tools have become strategic commercial products capable of generating significant revenue. Companies, therefore, tend to protect with trade secrets the specifications that make their models more efficient or innovative. But how do they actually work? These models receive a text input, a question, a command, a request, and return a coherent output in the form of text. The real innovation is that today anyone can interact directly with the artificial intelligence model without needing a technical intermediary. Until a few years ago, you needed a developer or a researcher to build the interface between the user and the model. Today, thanks to language models, the interaction is direct, natural, and accessible. This is one of the most significant revolutions in generative artificial intelligence. It has democratized access to artificial intelligence, making it a tool within everyone's reach. And for this very reason, it's essential to understand how it works, its limitations, and its implications. The way language models work is based on principles similar to those we've already seen for neural networks. A network is built and a training phase is started, during which the model learns the task it needs to perform. Again, without getting into technical details, what matters for us to understand is the basic mechanism of learning. During training, the model is presented with incomplete sentences from which one or more words have been removed. The goal is to teach the network to predict the missing word. Another common approach instead involves removing the last word of the sentence and asking the model to predict it. The network then receives a sequence of words, or more precisely, tokens, that is, linguistic units, and generates a prediction. If the prediction is correct, the process continues. If it's wrong, the model adjusts. The weights of the internal connections, just as we saw in the case of neural networks for image classification. This process is repeated millions, billions, even hundreds of billions of times on enormous amounts of sentences. During this phase, the network doesn't simply memorize the sentences, but learns to represent words and their relationships in a mathematical space. These representations are called embeddings. They are latent representations, meaning numerical vectors that capture the meaning of words based on the context in which they appear. In other words, the artificial agent learns to understand that words like dog and cat are semantically closer to each other than cat and car. The result is a probabilistic model of natural language, capable of generating coherent texts, answering questions, completing sentences, and engaging in conversation with the user. Once the language has been understood and represented within the model, it becomes possible to move from one medium to another. Today, in fact, we are able to build models that, starting from a text input, can generate images, graphics, audio, or video. In the same way, we can do the opposite, start from an image and obtain a textual description, or generate a video starting from a sequence of images. This ability to translate content between different formats is one of the most fascinating frontiers of generative artificial intelligence. It's no longer just about understanding language, but about creating new content in a fluid, creative, and multimodal way.